Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. How can we find partial sums of an infinite geometric series? Well, it is possible, and that's what we're going to tackle in this video today. It says the sum S of n, or S sub n, of the first n terms of an infinite series is called a partial sum. Now, this partial sum may approach a limiting value in a geometric series. So think about geometric series, we are multiplying by a common ratio. And so if we think about when we are multiplying, right, obviously if we're multiplying by something that's greater than 1 or absolute value of 1, then that series is going to continue on forever, right? We're not going to be able to find the sum of that. However, if we do have a common ratio that's a fraction, then that might approach a limiting value, right? Which is what we're going to see in this video today. And so we're going to use this information in the video today to help us actually find the sums of an infinite geometric series when that R value is a fraction less than 1, okay? So we're going to use this video to kind of help springboard us into the next video that we'll do when we find the sum of an infinite geometric series. So here's our example. We have 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32, so on and so forth. It ends in an ellipsis, dot, 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 so we know it is infinite. It continues on forever. So what we can do is find partial sums. So let's say we wanted to just find the sum of our first term, right, S sub 1. So this is equal to 1/2, which is just equal to 0.5 if we want to write it as a decimal, okay? So let's continue this on here, and let's see if our value, the sum, our partial sum of the series is going to approach a certain value. So now we would say the sum of the first two terms would be 1/2 plus 1/4, and we know that would be equal to 0.75. Now let's do that for the first three terms. So 1/2 plus 1/4 plus 1/8, and that's going to be approximately 0.88 once we plug that into our calculator and evaluate that, okay? Now for S sub 4, that's going to be our first four terms. So 1/2 plus 1/4 plus 1/8 plus 1/16, and that's going to give us approximately 0.94. Now we have a fifth term. Let's do that one more time. So the sum of all five terms that are visible to us on the screen right now, 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32, and that's going to give us approximately 0.97. So let's take a look at our values that we're seeing here: 0.5, 0.75, 0.88, 0.94, and 0.97. Right? If we look at those values, what value does it look like we are approaching? Well, it appears that we are approaching, so approaches 1, right? We are appearing to approach 1. And so in this case, we could actually come up with a formula that would allow us to find the sum of this infinite geometric series. So right now we're just looking at partial sums because we can tell that partial sums may approach a limiting value in a geometric series, especially when our common ratio is a fraction between 0 and 1. Okay, so that's how we can find partial sums of an infinite geometric series. And like I said, check out the next video when we actually use this information to come up with an equation that will help us find the sum of the infinite geometric series.